Now we are going to solve a problem which is based on radiocarbon dating. Here the problem number is 9.14. It is given in the inside the lesson of 9th chapter. What is mentioned in the problem? KEEZHADI, a small hamlet, has become one of the very important archaeological places of Tamil Nadu. It is located in Sivagangai district. A lot of artifacts, gold coins, pottery, beads, iron tools, jewelry and charcoal etc. have been unearthed in KEEZHADI, which have given substantial evidence that an ancient urban civilization had thrived on the banks of river Vaigai. To determine the age of the materials, the charcoal of 200 gram sent for carbon dating, which is given in the following figure. The activity of 6C14 is found to be 37 decays per second. You are asked to calculate the age of the charcoal. Here two data are given. One is activity of 6C14, that is 37 days is given. The another one is mass of the charcoal sent for carbon dating is given. Its value is 200 gram. Provided you should know the half-life period of the radiocarbon. Radiocarbon half-life value is 5730 years. By using these three data, you are asked to find out the age of the charcoal. Now we are going to do the first step in the problem. In the first step, we have to find out the decay constant of the carbon 14. The half-life period of the carbon 14 is 5730 years. By using this half-life period value, we have to find out the decay constant. The formula is lambda decay constant is equal to 0.6931 divided by T half. This is the formula. Substitute the value in the formula. Lambda is equal to, decay constant is equal to 0.6931 divided by 5730 years to be substituted. Later, the value of the years must be converted into seconds. So how will you convert 0.6931 divided by 5730? 1 year is equal to 365 days. Are you clear? 1 day is equal to 24 hours. 24 hours is equal to how many seconds? Is it clear? 24 hours is equal to, here everything to be converted one by one. Years to be converted into days, days to be converted into hours, hours to be converted into seconds. 1 hour is equal to 3600 seconds. So finally 5730 years is converted into second. After calculating this part, finally you will be getting the decay constant value. The decay constant value is 3.83 into 10 to the power of minus 12. Here seconds, it is in the denominator. So when it is brought up, that one becomes second inverse. So this is the value of decay constant. This is a decay constant of whom? The 6C14. Okay. Now I am going to tell you how to find out the total number of carbon atoms which are present in the sample. With the help of Avogadro's hypothesis, we have to find out. We know very well that in 12 gram, how much? In 12 gram of carbon, how many number of atoms are there? 6.023 into 10 to the power of 23 number of atoms are there in the case of which one? The carbon. 12 gram of carbon contains this many number of carbon atoms. Both are measured in terms of mole. Are you clear? So therefore, with the help of this Avogadro's hypothesis, we have to find out the above value. Now we are going to find out how many number of carbon atoms are present in 200 gram. 12 gram of carbon contains this many number of atoms. How to find out? Here, look at the simple formula. 6.023 into 10 to the power of 23. What is this? They are all number of atoms which are present in 1 mole of the carbon. Are you clear? This one contains, this one is having the mass of 12 gram of carbon. Therefore, divide this. 12 gram of carbon, that is present in 1 mole. That is very important. Are you clear? Now we are in a position to calculate the number of atoms which are present in the 200 gram. You simply just multiply 200 gram. You will get the answer. How the final unit will be? Our aim is to find out the number of atoms. Mole can be cancelled. Gram can be cancelled. The final answer will be in terms of number of atoms. So after calculating the final value, if everything is multiplied, the answer will be 1 into 10 to the power of 25 atoms. Are you clear? So this many number of atoms are present in 200 gram. So finally we have to write like this. 200 gram of charcoal. What is it? 200 gram of charcoal that contains how many number of atoms of carbon? 1 into 10 to the power of 25 number of carbon atoms are present. So this is the final conclusion. Understood? 200 grams of charcoal, that one contains 1 into 10 to the power of 25 number of atoms of carbon. So this is the final conclusion. Are you clear? This is step 2. Understood? In step 3, we are going to calculate the number of atoms which were present initially. Are you clear? When t is equal to 0. Are you clear? Number of atoms which were present initially, n naught to be found out when the time t is equal to 0. Already in law of radioactivity, while learning law of radioactivity, I have told that when time t is equal to 0, before the decay starts, some amount of total number of atoms were present initially. By the time, such number of atoms to be taken as n naught. Are you clear? That is to be found out now. Look at the other two more important things. Here I have written two things. When the charcoal sample, when it was alive, the ratio of 6C14 to the 6C12 atoms, in between these two atoms, that is a constant. So its value is 1.3 into 10 to the power of minus 12. This value it won't be given. You have to remember this. In the problem it won't be given. The ratio of 6C14 to the 6C12 atoms is always this much. It's a constant value. After the death, what will happen? The ratio it won't be constant. That you should know. That's why it is mentioned that alive. Here one more thing which was already found in the previous thing. 200 grams of charcoal, it contains how many number of carbon atoms? 1 into 10 to the power of 25 number of carbon atoms are present in 200 grams of charcoal. By using this two data, n naught can be calculated. How to write n naught? N naught, that is total number of atoms present initially, is equal to, these two must be multiplied. Are you clear? How to write this? Number of, what is this? Number of carbon atoms. Number of carbon atoms present in, write it in proper form, present in 200 grams of charcoal into the ratio of the 6C14 to 6C12, that ratio must be taken. Substitute both. Here number of atoms, carbon atom present in 200 gram is how much? 1 into 10 to the power of 25 number of atoms are present. Are you clear? It's a ratio. Simply you substitute 1.3 into 10 to the power of minus 12. After multiplying both, the answer will be 1.3 into 10 to the power of 13. 1.3 into 10 to the power of 13 number of atoms were present initially. Are you clear? We are talking about which one? This one, that you should know. Are you clear? So the total number of atoms, total number of which atom? Carbon 14 atoms which were present initially when t is equal to 0. Specifically I am saying These are all the number of atoms which are present. We are talking about radiocarbon. Are you clear? 1.3 into 10 to the power of 3, 14 atoms were present when the decay starts. Very important data, very interesting data also. Are you clear? So this is the method. So now we have found out N naught. Understood? So this is calculated in step 3. Now I am going to teach you the step 4. Here we are going to calculate the initial activity, that is called R naught. What is R naught? The number of decays per second that is to be calculated when the time t is equal to 0. Initially, before the decay, at the time of decay starts, are you clear? When the specimen that one was alive, when the t is equal to 0, we have to calculate the initial activity. Are you clear? That initial activity is called, what is this? R naught. The number of disintegrations per second when the t is equal to 0. By the time that should be calculated. To calculate R naught, these two are important. Without knowing lambda and N naught, R naught cannot be calculated. So what is the formula to calculate R naught? R naught, initial activity. Initial activity. R naught is equal to disintegration constant that should be multiplied by which one? N naught. What is N naught? Number of atoms present initially. Are you clear? This is a simple formula. Therefore, R naught is equal to, substitute both the two value, 3.83 into 10 to the power of minus 12 into 1.3 into 10 to the power of 13. Clear? This is the substituted value. So by using this, we are able to calculate the value of R naught. Here, the lambda that is given in terms of second inverse. Are you clear? So it should be written in terms of second inverse. Note down the units. Are you clear? This is in terms of second inverse. This is in terms of atoms. Multiply both. The R naught value will be, after multiplying you will get 50. Are you clear? 50. 50. After writing 50, what should be written? Atoms per second. So clear. Finally, you will be getting atoms per second. Instead of writing atoms per second, we can write it as decays per second. That is, 50 atoms are decaying per second. Therefore, we can write it as, straight away we can write it as 50 decays per second. So the unit is clear. It should be taken in that form. Understood? So if 50 decays are taking place in 1 second, the decays per second, that can be simply written as becquerel, 50 becquerel. That becquerel can be written as BQ. What is 1 BQ? 1 BQ is equal to 1 decay per 1 second. Are you clear? 1 disintegration per 1 second is equal to 1 becquerel. 50 decays per second can be written as 50 becquerel. So this is the method of calculating R naught. Understood? Now I am going to tell you how to derive the formula to calculate the age of the charcoal or specimen. For that we have to use this formula. Activity is equal to, activity is nothing but capital R. Initial activity e power of minus lambda t. This formula was already taught. Are you clear? Very important one. Now you bring this factor down. R divided by R naught is equal to e power of minus lambda t. Here t is nothing but the age of the specimen. Now we have to get the formula to find out the expression for t. So what we have to do? You reciprocate this. After reciprocation, what will happen? On both sides we can reciprocate. R naught divided by R. This one is reciprocated. If this one is reciprocated, what you will get? E power of lambda t you will get. Now we have to take log on both sides. Take log on both sides. Log to the base e R naught divided by R can be written. That could be written within the bracket. Log of e power of lambda t can be written. We know very well that log to the base e power of lambda t can be simply written as lambda t. Are you clear? So I am writing this factor. So after simplification, that one becomes lambda t is equal to What is the remaining thing? Log to the base e r naught divided by r. So in that format you will get. Understood? Here the final expression is, the thing is, t can be obtained. T, that is age of the specimen, is equal to 1 by lambda. This one is cross multiplied. Log to the base e r naught divided by r. So specifically this step is very important. You should know how to derive the expression for the age of the specimen. So without learning the proper form, it's clear we can't proceed further. That's why I have taught specially, especially for calculating the t value, age of the specimen. Are you clear? This is a required thing. Look at the expression here. R naught is required, R is required, lambda is required. Here R is given in the problem. Now we know the value of lambda and R naught. By knowing R naught and lambda, by substituting R, we are able to get the t value, age of the specimen. Are you clear? Now we are in the final step. In this final step, we are going to calculate the age of the charcoal piece or age of the specimen. Look at the formula. T is equal to 1 by lambda log to the base e r naught divided by r is the formula. Already we know the value of r naught and r. Substitute here. Log to the base e, r naught value is 50, r value is 37. After finding this value, you will get 50 divided by 37 will be equal to 1.351. Log to the base e, 1.351 value, that is to be seen from the natural logarithmic base. Its value is 0.3008. Here, substitute the value. T is equal to, lambda value is already found out, 1 divided by 3.83 into 10 to the power of minus 12 into log to the base e. This part was already calculated. Its value can be roughly taken as into 0.31. It can be written like this. So after calculation, the answer will be available in terms of seconds. The answer will be 7.86 into 10 to the power of 10. 7.86 into 10 to the power of 10 seconds. So this is the age of the charcoal. Are you clear? Age of the specimen. But it is in terms of seconds. So we have to find out the value in terms of years. This one should be converted into in terms of years. Look at that. 1 year is equal to 3.5156 into 10 to the power of 7 seconds. Here this many number of seconds are there. How to convert in terms of years? In terms of years, this value to be converted. In terms of years. How to find out the calculated value? 7.86 into 10 to the power of 10, that is to be divided by this value. How much? 3.156 into 10 to the power of 7. Are you clear? 7. This is the substituted value. Are you clear? Now, after calculation, the answer it comes around 2500. 2500 years. Approximately, we are able to estimate the age of the charcoal or age of the specimen. So this is the method of finding the age of the ancient things by using radiocarbon dating method. Are you clear? Very interesting problem. Okay.